Okay, let's go ahead and put down the oxidation numbers for each of these compounds, the ions within them, or the ions, and then the name for them. So how about a cation for the first one? What? Hydrogen plus one? Yeah, the cation in this case is the hydrogen, and its charge is the +1. And then the anion? Chloride, and its charge is a -1. And the name of it? Hydrochloric acid. Why is it doing that? Weird. Yep, hydrochloric acid. All right, the next one. Cation. Magnesium with a +2 charge. And the anion? Sulfur with a -2 charge. And then the name of it? Why is it doing that?
It's like moving as you're writing.
As I'm writing, which makes it really annoying. Magnesium sulfide. Great. All right. How about the next one? Cation?
Hydrogen +1.
I have a hydrogen,
+1.
and I have a +1 charge. That is just weird. Anything else?
Do we need to put it in parentheses or two?
Nope. Every hydrogen in there will have that charge, and it doesn't matter. At no time will you'll ever have the same atom in a substance, and it'll have two different charges. So then if you just tell me what its charge is once, then I know all of the instances of that element have that charge. Are you okay with that? The charge on that oxygen is -2, right? So then if I've got a charge on the oxygen that's a -2, but there are 4 of them, what's that work out to? -8. And so I've got 2 +1s in the hydrogens, so then the sulfur's charge is going to be a +6 to cancel that. And what's the name of this thing? Sulfuric acid? Why is it sulfuric acid? So there's a hydrogen in the front, so that's acid. There's an oxygen in it, so we don't say hydro like we said with the hydrochloric. One more piece. Why is it sulfuric acid? Because it's the polyatomic ion sulfate, so it ends in an 8, so then we change it to an ic. How about for the next one? Let's do the anion first. The anion's charge, that's oxygen, it's in a -2, so then what must the iodide's charge be? +7? We need to have one leftover negative charge, and right now we've got 8 with the oxygens. And if I have the iodine be a +7, then I still have 1 leftover negative. And what is this thing? Wow. This couldn't be more annoying. Periodate? It's per because it's 4 oxygens, and 8 because it's more oxygens. And the last one here? Manganese with a +3 charge? You okay with that? And so the iodine has a charge of -1. And what's the name of this? Why the Roman numeral 3?
Because
Manganese can have possible different charges.
Manganese can have multiple possible oxidation states, so you need to tell me which one. If you got the name manganese oxide or iodide, what would you do with it? If I said manganese iodide, how would you come up with the formula?
ask me which one.
Yeah, you can't, right? You could write down 6, 7 different things. Which one am I talking about? Because they're all very different from each other. They have different colors, different densities, specific heats, all those things are different. So you gotta tell me. Alrighty.
I have a question on the IO4.
Uh-huh.
How come you don't say iodine oxide? No, for no reasons? You know, because there's only 3 of them, the other word. Is it it's not a polyatomic, is it?
Yeah?
Yeah.
There's a
Oh,
charge
yeah.
on it, right?
Oh, okay, but is it on our list?
Yep.
Oh, never mind then.
You're correct. There are lots that aren't on your list, but that one's on it, for sure. If a molecule is polar, what's occurring? Hmm,
Where the electrons are being shared, not transferred.
nope.
They're being pulled closer to the larger atom. It's got a bigger nucleus. I mean, in a covalent bonded molecule.
We're close. Something to do with it for sure. An atom that has higher electronegativity, but not too high. So what kind of bond, what kind of atoms, well, I'm gonna ask that, what kind of molecules can? So let's answer that question. What kind of molecules can be polar? Only covalent ones, all right, so only covalent. And which ones can't? Ionic. Why not? They don't, ionic is no sharing and covalent is sharing. So go back to our first question. In a molecule that is polar, what's occurring? That's it. Uneven sharing of electrons. They're supposed to be evenly shared, but some atom has higher electronegativity, high enough to drag the electrons that are supposed to be in that bond away from the other atom. So uneven sharing. And so since it's uneven sharing, does it make sense that you can't have that in an ionic bond? Because there isn't any sharing at all, so it's moot. All right, so I want draw the Lewis structure, 3D model, and if applicable, 3D Vesper shape. Also name each structure and indicate if it, seems to be words missing. If it's polar or non-polar is what that was supposed to say. Huh, alrighty. Okay, so how do I draw a Lewis structure for this first one?
So with the carbon in the center, and
It's not where we start though. That's, I have to figure out how many valence electrons I'm working with. So 4 for the carbon, 1 for each of the hydrogens, and 7 for the fluorine. So 14. So 14 electrons. So now I'll go ahead and I'll throw the carbon in the middle, and then I'll put a hydrogen and a hydrogen and a hydrogen and a fluorine. So at this point, are any of the atoms happy? The carbon and the hydrogens. All of them are happy except for the fluorine, right? How many electrons have I used so far? 8. And I have how many left? 6. 2, 2, 2, 2, 2, 2. Okay. So I've used all 14 of my electrons. Everybody's satisfied. Alrighty. Is this, is there a Vesper structure for this molecule? No. You're correct. Vesper only happens when the central atom has what? Lone pair or multiple lone pairs of electrons. There aren't any on this one. They're all atoms. So what's the shape of this molecule?
tetrahedral.
This is a tetrahedral. Actually, I really didn't mean to ask you what the name of either one of these, but did anybody come up with a name for this? Yep, good job. It's fluoromethane, but I shouldn't have asked you that, but good job. Is this molecule polar? That's the question I wanted to ask.
Yes.
It is. How come? The fluorine's got an electronegativity of 4, and the carbon's got an electronegativity of about 2.5. So that's definitely between 0.5 and 0.9. So the electrons in this bond right here are being drugged towards the fluorine, which makes this side of the molecule partially negative and this side of the molecule partially positive. So will this stuff mix with water? Yes, because water is also polar. Are we okay with that? So how many do we have for nitrogen electrons? Five plus 7 times 3. So we have 26 total electrons to deal with. Who are you going to put in the middle? Can you give me a couple of reasons why you're going to put nitrogen in the middle? One, it makes more bonds. That's the best part. The other part is which one of the iodines do you put in the middle? So it's which one of these isn't like the other kind of deal. So I've got a nitrogen and an iodide and an iodide and an iodide. Anybody happy? Nope, nobody's happy. So let's start making people happy. What if I put lone pairs of electrons around these iodides? So now all the iodides are happy. How many electrons have I used? 24. Got 2 left over, which is great because the nitrogen would really like a lone pair of electrons as well. And so there you go. We've got a lone pair of electrons on everybody's happy. So what's the deal with this guy here?
Tetrahedral.
It's how many things are around it? No,
4.
there are 4 things around it. There's a nitrogen, and then there's a lone pair of electrons, and an iodide, and an iodide, and an iodide. So it's got a tetrahedral shape, right? What's its molecular shape? So tetrahedral, and I cover up that lone pair of electrons, and what do I have left? It's a triangle. Are we okay with that? But it's pyramidal. It's not flat. So this shape up here with the electrons here, this is tetrahedral. And this one down here is what? Trigonal pyramidal. And one other thing we have to talk about, let's go with, I don't know, maybe that's too big. What's iodide's electronegativity? Okay, so I've got 2.66, and then the nitrogens? 3. Okay, so do I have a big difference in electronegativity? Not so much. So what would you say for this guy, polar or nonpolar? Probably nonpolar, right? Okay.